Introduction. Bipolar junction transistor (BJT) is a type of semiconductor device that is most widely used in electronic devices. This transistor is made of silicon or germanium material. The transistor functions as an amplifier and electronic switch. As we can see in the slide, there are two types of BJT. I will go through for NPN first. The NPN consists the three layer of semiconductor material. As we can see in the figure, P-type material sandwiched between two layer and N-type material. Two layer of N-type materials. The three layers are called the emitter, base, and collector. The base is P-type. In an PNP transistor, the majority charge carries are electron. When the small currents flows between the base and emitter in forward bias, it controls a large current flowing between the collector and emitter. This characteristic allows NPN transistor to amplify signals or act as electronic switch in various circuits.
Next, bipolar junction transistor PNP type. This diagram shows the symbol and construction structure of BJT type PNP. As for the symbol, it's the same as NPN, but the difference is only in emitter part that show the direction of the arrow, which means reverse bias. The construction structure of the PNP transistor show the N material sandwiched between two layers of P material. Just like the NPN transistor, the PNP also has three material layers that each N has a collector, base, and emitter N, as shown in figure. The diagram shows the NPN type bipolar transistor amplifier circuit. This bipolar transistor works as common emitter amplifier. When the base emitter N is forward biased by the supply voltage V and the base collector N is reverse biased by the VCC supply, resistor RB is used to limit the value of the current that pass through the emitter base N, while resistor RC as a load resistor to reduce the voltage across it. To make it easier for everyone, we have prepared the meaning of the summary in the circuit. IB is stand for DC base current, IE is DC emitter current, IC is DC collector current, VBE is DC voltage at base with respect to emitter, VCB is DC voltage at collector with respect to base, VCE is DC voltage at collector with respect to emitter.
Okay, let's move to the graph. This is NPN BJT graph. It's about IC against VCE. What is IC? What is IB? And what is VCE? VCE is voltage collector emitter, IC is collector current, and IB is base current. As we see, we have three zones, which is active region, cut-off zone, and saturation zone. Why it's cut-off zone? As usually, we use 0.7 volt, which is silicon types. We need to get above 0.7 volt to transistor work. So, as we expected, the saturation zone is against the cut-off zone. When the voltage is above 0.7, so the transistor is fully conducting. How about the active region? Okay, the active region is about when we want to get amplified. So the collector current increase linearly with VCE. As example, if you want to use the microphone, we want to amplify the volume, we need this active region to work. So we need over 0.7 volt to get work. Okay, so why at the first of the graph is curve. This curve is formed by when the voltage is from 0 to over 0.7 volt. It will increase slightly above 0.7 and will be active and get in active region. So IB must be constant and being affected by IC. IC is affect the IB. When the IC is increased, IB will increase.
And circuit, we want to find the IC, IB, IE, and VC. So first we want to find the IB. We use voltage Kirchhoff law, VBB, IBRB, VBE, and get information in this formula and get the IB equals to 50 microampere. And IC, we use this formula and into this formula and we get the IC equals to 3 milliampere. And IE, same, we find that into the formula and get the IE equals to 3.02 milliampere. Find the VC, we want to Kirchhoff voltage law, VCC minus VC minus ICRC equal to 0, and find the VC is 4 volt, and VB equals to VBE plus VE, and we know that VB same like VBE because the VE is 0, and since that VC greater than VB, it can be said that the base collector junction in reverse bias. We want to find the VCE by using essay method and approximate method. And first we want to draw the simple circuit, and we want to find the VTH by using the R2 times VCC over R1 plus R2 and get the information into the formula and get the answer is negative 3.2 volt. Second, we know that R1 parallel with R2, and we just into the formula parallel and get a 8.6 k ohm. And third, we want to find the IB by using the KVL into this loop, and negative VTH plus RTH plus IB plus RE IE. We know that VBE is negative 0.7 because the PMP direction is like this. So we just get information into the formula and get IB is equal to negative microampere. Fourth, we want to use the VCE by using the KVL in this loop, and we know that IC equals to IE. Assume that IC equals to IE, and that's why IC is equals to negative 1.22 by using the IE formula beta plus 1 times IB and get the answer VCE negative 6V. And for the approximate method, we want to use the approximate method rules by checking approximate rules, which is beta times RE greater than or equals to 10 R2, and we check that it can apply the approximate method. Second, we want to find the VB by using the VB formula R2 times VCC over R1 plus R2, and we get the information into the formula and get the VB is negative 3.2 volt. And third, we want to find the VE by using the KVL for VB minus VBE minus VE equal to 0, and get the VE equals to negative 2.5 volt. And fourth, we want to find the IE by using the Ohm's law VE over RE, and get the answer is negative 1.25 milliampere. And lastly, we want to find the VCE by using the KVL in this loop, and we know that IC and IE is same, and we know that this is same like IE, so we try to find the IE and get a negative 1.25 milliampere, and get the information given to the formula and get the VCE equals to negative 6 volt.